Okay, I want to do some more about graphing because I know that graphing can be a little bit of a struggle for some, and I want to kind of go over these a little bit. I highly encourage you to write this down because sometimes this helps. So I want to kind of go over this. So first off, remember back in our videos is that we have our Cartesian coordinate system, which is we're known for our 2D graphing, our X's and Y's. So quadrant 1, remember quadrant 1, quadrant 2, 3, and 4. All positive, negative and positive, all negative, and positive negative. And that's usually how it would go. And remember, you always have your X's here and your Y's. And remember, you're always graphing X first, then Y. Always X, then Y. So, I want to kind of go over what the domain, range, our equation here, and these two here. And this will make sense in a little bit. So, I kind of want to touch on this a little bit. Your domain is all your X values. It's all your X values. Your range is all your Y values. So let's do domain and range real quick. Okay, so over here I'm going to do a little graph. Okay, so I'm going to do a little graph. I'll do a little graph. Remember, this is your X, that's your Y. I'll make a little graph. So let's say that I'm going to give you an equation. Well, I give you this. Okay. Something like that. It's nice to have some graph paper. Okay. So this is a linear line, and it goes positive. Positive, remember? You're looking at it from left to right, so positive. What's the domain? Well, the domain says all the X values. Does this thing ever stop? So, does this line ever stop? Does this line ever stop? And the answer is no. No. So the domain is what we call all numbers. So for this, usually we put D for domain is ... all real. All real. Or all X's. Anything works for the domain. Everything works for the X's. For the X's, everything works. Everything you put in for X works. Well, so what about this range? So now we need to figure out what we need to do for the range. So, usually the range is with R. So the range, remember, is all the Y values. Well, all the Y values, does this line ever stop? Does this line ever stop? No, it keeps going. So we can continue to use all the Y's. So the range is the same thing. So all real and all Y's. Everything works. So for both of these, any number, this is all real. These go on forever. And as you're getting closer and closer to more advanced mathematics, can I say this? Negative infinity to positive infinity? Negative infinity to positive infinity? Can I say that to you? If this thing goes on and on forever, that means I can put any number for x in here and any value for y, and I can still get that number. I can put billion in there. I can put a trillion in there. It'd still be the same. You will still get an answer. Yeah, depending on your equation. So my domain and range is all numbers. Well, maybe you don't believe me. Well, let's try one. Let's try one. Well, this one should be really nice. Y equals x. What's the slope? So, what's the slope? Well, the slope, remember, is 1 over 1. So 1 over 1. Remember, it's that number in front of the x. So that means it's almost like this. It's going up and up and up forever. So I want to test your theory. Okay. So let's test the theory. X and Y. Put in any number here. By the way, that's 1 million. 1m is 1 million. Put those numbers in. What do you get? Let's see. If I put in -1 into my x, I should have this. Well, that's -1. Well, that's 100. And you can kind of see the pattern, right? So I can put in anything and this thing will work. There's no stop to it. And that's where this goes on forever. Okay? So that's a good explanation. Does all graphs do this? There is some limitations. There is going to be some limitations someday. Probably not right now, but you should at least know what domain and range are. Domain is pretty much all the values I can put into my x's. All these values that I can put into my x's that make this true. What about my range? Well, my range are all my y values that make this true. Well, how many y values am I getting here? I'm getting the same amount. There's no stop to it. And sometimes this is not always easy to see. You might have to do a graph. And I tell you what, I show you one graph that doesn't always, that one of these fails, or it's very limited. This is one type of graph. Here's your graph. That's a graph. This is your equation. And this equation goes down. Well, what's the domain? Well, I can put in any number and get something because this thing keeps going and going and going. Remember? This thing keeps going and going and going forever. You can put any value of x you want in there. But look at the y's. Where does your y go into? Well, your y goes, uh-oh. It stops right there and continues down here. So what I mean by this is that your range is limited. The range is limited. It's limited. But the domain, so you have a limited range. Okay? So that's pretty much it involved graphing, but we still have these kind of things down here. So let's give you some input about those real quick. Just real quick. So let's look at one of these. Y equals 3. I don't know what that looks like. But what can you do? Make a t-table. What's y always going to be? Always what? 3. Always 3. What numbers can I put in for x? What numbers? So what numbers can I put in for x? Anything. Keep going. So now, if you were to graph this, 0, 3. So 0, 1, 3. 2, 3. 3, 3. Looks like that. So we can say this is a horizontal line. We can say this is a horizontal line. What's the slope of a horizontal line? Slope is 0 because it's not rising or decreasing. It's just the same. So 0. So anytime that you see something that looks like this, there you go. It's always going to have a horizontal line. Okay? What about the next one? X equals 2. Okay. I don't know anything about this. Make a t-table. What are always x's? Okay. What can you do for the y's? Anything you want. So, I don't know. I try to use positive numbers because it makes it a little bit more sense. But if you can use any number you want, any number, but you have to remember, you're gonna have to graph it. So be very careful. So on this, let's make a graph. So, two. 2 on the x. So 2 on the x, 0. 2 on the x, 1. Remember to do your points. 2, 1, 2, 3. What's kind of forming there? It's a vertical line. It's a vertical line. The slope is undefined. It's undefined. There's no, straight up, straight down, there's no slope to it. There's no slope. If your building, the building that you're living in right now, if it's not vertical like this, maybe go like this, well, look at what happens. The line's going to flow down. So it has to be straight up like this, and it has no slope. No slope. So you can say undefined, or you can say no slope. Some students, they might say, oh, it has no slope. That's fine. But really, it's undefined slope. But be very careful. Don't get these two mixed up. 0 and no slope. Sometimes students get those mixed up. They might say, oh, something like this has no slope. Be careful. Be careful, because some students can say a line can have no slope. Just be careful how you say it. All right. Hopefully that was okay for more about graphing. That cleared things up a little bit that we don't do in class. So, yeah. Okay, questions?